Slide 1. Advanced Python, Decorators and Generators. Welcome to this session on Decorators and Generators in Python. These are two advanced features that help make your code cleaner, more readable, and more powerful. Today, we will learn what they are, how they work, and why they are useful. Slide 2. What are decorators? Decorators allow you to modify or extend the behavior of functions without changing their code. They are applied using the symbol, followed by the decorator name. This lets you wrap a function with extra functionality in a clean and reusable way. Slide 3. Decorator example. Here's an example of a simple decorator. We define a decorator function that takes another function as input. Inside it, we define a wrapper function that runs code before and after calling the original function. When we use the symbol to apply the decorator, the wrapper logic is automatically applied when the function is called. Slide 4. Use cases for decorators. Decorators are commonly used for logging, authentication, timing how long a function takes to run, and restricting access. They help separate concerns by allowing you to keep the main function logic clean while handling other responsibilities in the decorator. Slide 5. What are generators? Generators are special functions that return a sequence of values using the yield keyword. Unlike normal functions that return once, generators pause and resume their execution. This makes them memory efficient and perfect for handling large datasets or infinite sequences. Slide 6. Generator example. In this example, we define a function that counts up to a maximum number. Each time the yield statement is reached, the current value is returned and the function pauses. When called again, it resumes from where it left off. This allows us to iterate through a series of values one by one. Slide 7. Use cases for generators. Generators are ideal for reading large files, streaming data, and handling sequences where storing everything in memory is not practical. They are commonly used in data processing pipelines and for lazy evaluation, where values are only produced when needed. Slide 8. Comparison return versus yield. Our return statement ends the function and sends back a value. A yield statement pauses the function and saves its state. When using yield, the function becomes a generator and returns a generator object that can be iterated. This allows you to process data more efficiently. Slide 9. Best practices use decorators when you want to add consistent behavior across multiple functions, such as logging or access checks. Use generators when processing large datasets or when you need to produce values one at a time. Keep both decorators and generators simple and add comments for clarity. Slide 10. Resources and next steps. To learn more, visit the official Python documentation on decorators and generators. Real Python also has excellent tutorials with examples. Try writing your own decorators and generators to practice. Thank you for joining this session.